Hello, let's say there's an object that's moving round and round along this circular path. And let's say it takes the object 1 second to travel from point A to point B. How would you describe the speed of this object? So you can describe it using the linear velocity, in which case you'll say that v is equals to 3 cm per second, because it travels 3 cm in 1 second. Or you can describe it in terms of its angular velocity, in which case you are going to say omega is equals to 45 degrees per second. Or in terms of radian, then you'll say pi over 4 radians per second. Or simply 0.79 radians per second. Basically, linear velocity is the cm per second speed, alright? And angular velocity is the radian per second speed. Let me just advertise this identity to you. Omega is 2 pi over t, which is also equals to 2 pi f. So if the object is doing this circular path periodically, then the omega is also equals to 2 pi divided by the period, because the object completes 2 pi radians every one period, right? And of course, f is 1 over t. So this is a very useful identity that you should have at the front of your head. Okay, is there a relationship between v and omega? Definitely there is. So we start from s equals to r theta. So the arc length is equals to the radius times theta. Differentiate both sides. Then pull out the constant r, right? What is ds dt? Isn't that just the linear velocity? And what is d theta dt? The rate of change of angular displacement. That would be just omega. So v is equals to r omega. So this is another formula which is very important. So keep it at the front of your head. Okay, let's familiarize ourselves with the idea of v is equals to r omega. So let's say we have two runners here. They are running around the tracks, and this guy is taking the outer lane. Let's say both of them have the same linear velocity. So they have the same v. So do they have the same omega? Can you see that the inner one has twice the omega as the one on the outer lane? Yeah, because it's completing 1, 2, right? By the time this one has finished 2 rounds, this guy has only done 1 round. Let's see it again. That's 1, that's 2. It's quite simple really. If v is the same, then the one with double the r must have half the omega. For both the runners to have the same omega, to complete the same number of laps per unit time, then they must have different v, isn't it? So the one on the outer lane must have twice the linear velocity. So do you notice? The one on the outer lane is actually running at double the speed, but it completes the same number of laps per second. I hope you have a good idea of the difference between the linear velocity v and the angular velocity omega. That's all. Ta-ta!